Okay, the last 2 days of notes that we have in this unit are going to cover graphing what are called rational functions. Here's the idea with a rational function. A rational function is going to be a fraction where the numerator and or the denominator are polynomials. So the numerator and or the denominator have fractions in them, have variables in them rather. So you're going to see there's 3 examples here. 1 over x, that's a rational function. Like I said, just a fraction. Then you have f of x, you have g of x, they're all fractions. We're going to learn how to graph those. You will see an example here to the right. We've seen pictures like this before when we've done domain and range. The thing that you need to know with a rational function is its behavior is a little bit different than a normal graph in that it has, if you remember, what are called asymptotes. Asymptotes are kind of lines that are understood to be on the graph, that the graph approaches but never touches. And so oftentimes you're going to have a horizontal asymptote, like we do here. You'll see as the graph goes far to the left or far to the right, the graph is going to approach that asymptote, but it doesn't touch it. Doesn't touch it, doesn't cross it. And then oftentimes there's going to be at least one vertical, sometimes there's more than that, asymptote as well. And so you'll see on either side of that vertical asymptote, the graph is going to approach it, it's not going to cross it. Now, it is possible to cross an asymptote. We're not going to handle that. We are going to do a very general, quick overview of these graphs. We're not going to get into the fine, nitty-gritty details. Today is the background. Today is how do I find the intercepts, how do I find the asymptotes, how do I graph a basic graph. So that's what we're going to start with. Everything today is going to come down to the same function. So every question I ask you is going to be based off of this function. Ultimately, where we need to get to is we need to be able to graph. That's the biggest thing we need to be able to do. When we graph, we have to be able to find the intercepts. So when we say x-intercept, remember that means that y is 0. Y-intercept means that x is 0. We're going to start by finding the y-intercept because in my opinion it's a little bit easier to find. Y-intercept means that x is 0. F of x is really just y. So I have y equals, if I plug in a 0 for x, I get 0 subtract 2 over 0 plus 1. Order of operations, remember simplify the numerator and denominator before you divide. So we get negative 2 over 1, which simplifies to negative 2. Intercepts we've talked about before, I want expressed as a point. So we would say the y-intercept is the point 0, comma, negative 2. X-intercept, like I said, is a little bit more difficult to find. X-intercept, and there could be more than one, is the point or points where y is 0. So we're going to use the same equation, but this time we're going to put a 0 in for y. Okay, I think it's easier to solve something like this when we have 2 fractions set equal to each other. So that 0, I can write as 0 over 1, because 0 is the same as 0 divided by 1. How do I solve when I have 2 fractions set equal to each other? Cross multiply. Yeah, cross multiply. So 0 times x plus 1 is just 0. And then we have 1 times x minus 2. So we get 0 equals x minus 2 when I distribute that 1, which gives us an x value of 2. Again, though, I want that expressed as a point, so that is the point 2, comma 0. So we see we have 1 x-intercept, 1 y-intercept. I want us to note, though, you're not always going to have intercepts. So if we look at the example that we looked at in the beginning, you'll see there's no x or y-intercept. The graph never crosses the x-axis, it never crosses the y-axis. And that's because we have those asymptotes there. So just know that. There's no fast, hard rule.
Are we able to like assume that by like if we solve it like this and there's no picture, like are we able to see that there's no x and y-intercepts just by solving it like this?
Yes. So if you solve like this and there's no x-intercept or y-intercept, for example,
Yeah.
you're going to end up with a false statement. So something like 0 equals 2. That tells you that you don't have an intercept.
Okay.
Okay, so that's the first thing that you're going to have to be able to do on your homework is you're going to have to be able to find the intercepts. Next step in graphing, so again, remember where we're heading is we want to be able to graph this function, is we have to be able to find those vertical asymptotes, or those asymptotes in general, both vertical and horizontal. Here's how you find them. For a vertical asymptote, you are going to set the denominator equal to 0. So we're going to do that, and then we're going to talk about why. Okay, so in our case, we set the denominator equal to 0. When we solve for x, we get x equals -1. That is our vertical asymptote then. So what that means, if you think back to the picture, is there's going to be an imaginary line at x equals -1, that's vertical, that our graph doesn't touch. If we think deep, that should make sense. If we put -1 into our function, we get 0 in the denominator. Do you remember talking about how we can't divide by 0? So then it should make sense that our graph never actually gets to x equals -1. It'll be on either side, but it'll never actually get to -1. What's important about vertical asymptotes, or another piece that's important, is the behavior along them. So again, what's going to happen is at -1, about here, we're going to have this asymptote. So we're going to have a part of the graph to the left, and we're going to have a part of the graph to the right. Sometimes those parts will go in opposite directions. Sometimes they will go in the same direction. What I mean by that, if we look at the example that we had initially, here's our vertical asymptote. You will notice that on each side, the graph goes in opposite directions. So on each side, the graph goes in opposite directions. The way you figure out if it's opposite or the same is by the power that's on the asymptote. So behavior along the vertical asymptote. If we have an odd power, the graph will go in different directions. If we have an even power, we will go in the same direction. Okay, and here's what I mean by that. In our denominator, this x plus 1 is to the first power. I can't really see that. First power. So that first power is odd, which tells us the graph is going to go in different directions. Along the vertical asymptote. So one will go up and one will go down. If it was x plus 1, that quantity squared, then we would be going in the same direction. But in any odd power, we're always going to go in opposite directions. Okay, so that's the vertical asymptote. We also have to be able to find the horizontal asymptote. Here's how you're going to do that. You are going to compare the degree of the numerator to the denominator. And by degree, we mean highest power. There are 3 things that could happen. There are 3 different cases. It could be that the numerator has a power that is smaller than the denominator. In that case, your asymptote is y equals 0. So an example would be if we had f of x is equal to 1 over x minus 3. the degree in the numerator here is 0, x to the 0 power. The denominator is x to the first. Because the numerator is smaller, we get y equals 0. So that's the first case. Second case, the degree in the numerator is equal to the degree in the denominator. What you will do then is you will divide the lead coefficients. So an example would be the one that we are looking at. F of x is equal to x minus 2 over x plus 1. In this case, our degrees are the same. We have x to the first, x to the first. So what we do then is we divide the numbers out in front. So we have 1 over 1, which gives us y equals 1. So that is our horizontal asymptote.
Like on the first one, when the numerator its degree is less than the denominator, is what do you? Is that like so 1 is raised to the first power?
So it's always whatever power x is to. In the numerator, because there's no x, that's considered a power of 0.
Oh, got it.
Okay, so either the numerator is less than the denominator, the numerator is equal to the denominator, or last case would be that the degree of the numerator is greater than the degree of the denominator. So that would be something like f of x is equal to x squared over x plus 1. Numerator has a higher power than the denominator does. So in this case, there is no horizontal asymptote. I will tell you for our purposes, we will be focusing on the first two. So you don't need to worry about the no horizontal asymptote. What you need to worry about is my asymptote 0 or am I dividing the coefficients? We're not going to look at cases where we have no horizontal asymptote. Okay, questions for me before we put this together and graph? Okay, go to the next page. We are going to finish examples 3 and 4, and then we will take a break. Okay, in your homework, you need to be able to put it all together and actually graph. When it just says plain old graph, here's what you have to do. You have to find the x-intercept, or x-intercepts. You got to find the y-intercept. You have to find the vertical asymptote. You got to find the horizontal asymptote. Luckily for us, this is the same function we've been working with, so we already found all of that information. Our x-intercept, if you remember, was 2, 0. Our y-intercept was 0, -2. Our vertical asymptote was at x equals -1. And our horizontal asymptote was at y equals 1. All of that we found on the previous page. All I did is just copy it over. Okay, we are going to start by putting this information on the graph and then see what it tells us. First thing I'm going to do is the asymptotes. X equals -1 is going to be this horizontal dashed line. And then we have a, vertical dashed line. We also have a horizontal dashed line. There. So those are our two asymptotes. Remember, the idea with an asymptote is the graph is going to approach both of those dashed lines but never touch them and not cross them. Then we're going to graph our two intercepts. So we have 2, 0, which is right here. And we have 0, -2, which is right here. Our graph is going to have two parts. There's always one part on each side of the vertical asymptote. These 2 points very clearly show us what the first part is going to look like. we know from this point to 0, we're going to come up and approach the asymptote. It is very important that your graph hugs the asymptote, but doesn't cross it, doesn't touch it. If you draw in such a way that your graph crosses or touches the asymptote, I'm going to take points off. So then from this intercept, we're going to come down and hit the other one, and again, approach this asymptote. So we're going to come down again and approach that asymptote. Again, shouldn't touch, shouldn't cross. Mine got really close, so hopefully yours gets less close. That's one part of the graph. That's the right side of the vertical asymptote. We need to figure out the left side. It's either going to be up or it's going to be down. If you remember, on the previous page, when we found this vertical asymptote, we looked at the behavior. And we said, because this denominator has an odd power, it's to the first power, we will be going in different directions. So what that suggests is that our graph should be up top here.
Do we just look at the denominator for the power?
Yep.
Okay.
Suggests our graph should be up here. If we're down here, we should be up here. Now, to verify that, we can plug in a number just for convenience sake. If this is -1, maybe I plug in -2 to find a point. So we're going to do that real quick. If we plug in -2, we get -2 subtract 2, -2 plus 1. So that'll give us -4 over -1, which is 4. So that is the point -2, comma 4. If we plot that, -2, comma 4, that's a point right up here, which checks out with what we said. We said we should be going in opposite directions. So what's going to happen is my graph is going to come up and approach the asymptote up here. And then it's going to round out and approach the horizontal asymptote. Again, approaching, not touching, not crossing.
Do we need to find a point, or can we just...
Okay, the question is, do we need to actually find this point? In all reality, no. No. If you know in your head, just by looking at the power, what's going to happen, I am perfectly fine with you sketching generally what's going to happen. If you feel more comfortable finding a point to verify that your behavior is correct, we can do that. We have one last thing to do. It's this question 4. It's not any graphing. All we're doing is answering some questions based off of the graph we just drew. Okay, this word is really important, or this term, asymptotic behavior. All that means is what's happening along the asymptote. All that means is what's happening along the asymptote. So when you see that term, like on a test or a final, don't get scared, just is telling you to look at the asymptote. So this is saying, as x goes to -1 from the right, f of x, y, goes to what? Okay, on our graph, as x goes to -1 from the right, here is our -1. As we're approaching -1 from the right, so that's here, f of x, or y, is going to -infinity. So as we're approaching -1 from the right, we're going to -infinity. Okay, likewise, as x is approaching -1 from the left, so here's our -1. If we approach from the left, f of x, again, that's just y is going to +infinity. I'm approaching from the left, my y goes to +infinity. Okay, this one's a little bit different. As x goes to infinity, f of x goes to infinity means x is getting bigger and bigger and bigger. We have to look at the graph. As x is getting bigger and bigger and bigger, that's over here. So as x is getting bigger and bigger and bigger, our y value is approaching that asymptote of 1. As we get bigger, we are approaching the asymptote. Again, though, we're never actually going to hit the asymptote. Okay, I have one thing to say before we take our break. First of all, do you have any questions for me? Okay, I want to give us a heads up of what your homework is going to look like. Sometimes on your homework, the question will be very specifically laid out. Find the intercepts, find the asymptotes. If it's a question like number 3 where it just plain old says graph, the expectation is you find the intercepts and you find the asymptotes. So you need to know to do that. If you don't have any work and you just have a graph, you will not get credit.